This is a model of Acheson & Glover's factory. This factory is used for making blocks, and as you can see there's three main sections to Acheson & Glover's block making factory. Section 1 is known as the dosing and mixing plant. Section 2 is the block making machine. Section 3 is the finger, car and curing chamber. Each section of the model is fully rotatable, as the main purpose of this model is a teaching aid. So the fact that each part is rotatable, it allows it much easier for the children to see exactly what's going on and allows them to visually see each part. Present in each floor is the blocks that hold each of the switches necessary to operate the floors. Each floor is clearly labelled, so as we can see, floor 1 is the dosing and mixing plant. The first stage of the dosing and mixing plant is that the slot doors of the hoppers open, allowing the raw materials such as sand and gravel to enter and exit onto the conveyors. The raw material then moves from this conveyor onto the raising conveyor. Both of these conveyors will operate simultaneously. The raising conveyor will transport the raw materials into the mixer. Once the weight limit, which allows the user or the operator to know that there's enough mixture in the mixer to create the concrete mix, a weight sensor will be activated. Because this is a teaching aid, the weight sensor is present outside of the mixer so that it is visible for the children to see how it operates. Once the conveyor transports the sand and gravel into the mixture, a weight limit will be reached. The weight sensor will then be activated. The weight sensor stops all conveyors and activates the mixing fan inside the mixer. The red LED allows the children to know that the mixer is activated. Finally, once the mixing process is stopped, the mixture can be tipped into the next floor, which is floor 2. I'd now like to demonstrate how the block making machine operates. So initially the concrete mixture will enter into this hopper here. The slot door will open, which is operated by a servo motor. The servo motor then closes after 3 seconds. Then the mixture of concrete travels along this conveyor. A motion sensor operates the forming stamp, which forms the concrete mixture into the shape of the cobbles or the brick blocks that has been made. Finally, the formed blocks or cobbles is transported into the next section via this conveyor here. I'd now like to demonstrate how the block making machine operates. Firstly, the on-off switch is turned on. The servo motor pulls out the slot door, which allows the gravel to enter, and is closed. The conveyor from the hopper takes it straight to the clamp. The motion sensor operates the stamper, which forms the blocks, and finally the formed blocks exit this conveyor. LEDs have been used in this demonstration. The red LED lets the children know that the conveyors are on. The green LED allows the children to know that the sensor has been activated. Floor 3 is the finger cure and curing chamber. On this floor there are 3 main parts. We have the conveyor, which transports the formed cobbles or blocks onto the finger car. The finger car will then lift the foreign blocks or cobbles on into the curing chamber. The curing chamber has a clear plastic back. This is so that children can easily see through each section of the floor. Also present in the curing chamber is racks, and the racks allow the cobbles to be set on it. Now, we also have a digital on-off switch which starts up the process. Also at the top of the curing chamber we have the temperature sensor, which is an analog switch, and this replicates what happens in the Aitken and Glover factory, because once the temperature gets too high in the curing chamber, the thermistor will sense this rise in temperature and turn on a fan. Also, an alarm will be set off to allow all personnel to exit the curing chamber before this process begins. I'll now demonstrate this process working. The body temperature of my hand will activate the thermistor, causing the alarm to go off and the fan to operate. A closer look at the conveyor and the finger car in operation. The chain and sprocket present in the finger car will lift the cobbles up into the racks of the curing chamber. The curing chamber also has the thermistor present, which is labelled to add to the efficiency of this model as a teaching aid. Each floor of the model factory can be lifted off the stand. The floors are on the shape of a gear. Each gear then can be easily connected to form a simple gear train. It is clear that each gear is connected and meshed together. The purpose of having a gear train is to show the children that this is an active and real-life example of a production line. It should be explained to the children that if one floor is missing from this production line, a finished product cannot be produced. For example, if floor 2 was removed, the finished product couldn't be produced because the mould for the blocks or cobbles could not be produced. Finally, throughout the factory logo AG is evident throughout. This is to add to the realism of this model and to allow the children to connect to the real life example of what it is.